So scientific notation multiplication. So what is scientific notation and why is it important anyway? Well, scientific notation is, as the name implies, scientific. But what's important is that I can keep track of really big numbers or really small numbers. All right, so let's remember how we might use this. So if I have an example, right, of something simple here. If I have 8,000, okay, 8,000 is a pretty small number. $8,000 or whatever, okay. If I want to write this in scientific notation, what this says is that I can write 8, and I move my decimal point, right? Where was my decimal point before? It was over here, so I go whoop, over here, move it over 3 places, and I write 8 times, and use a little x there. Don't confuse it with the actual x of algebra, times 10 to the actual power of 3, right? And if I wanted to write a small number, 0.00008, right? I want to write that as scientific notation. Instead of writing all my zeros out, I have to move my decimal point as well, right? So I go 1, 2, 3, 4, 5. So I'd move it 5 places, right? 1, 2, 3, 4, 5, as I showed right there. So that means that I'd write, instead of 8 times 10 to the positive 5, I'd write 8 times 10 to the minus 5. So that's a little bit of a review of scientific notation in general. But what about multiplication? Well, with multiplication, you have some steps here, right? I can multiply, and this will make sense when I write out an example, but I can multiply the coefficients. And coefficients simply means the numbers that are in front of my exponents. When I worked with instrumentation, we had coefficients that we'd load for, the instrument to read to give us the right answer for temperature or humidity or something like that. Okay, so multiply coefficients, and then I'm going to add all of the exponents. Okay, and so this is a reminder, right? How do I add exponents? Well, if I had x to the power of 2 multiplied by x to the power of 1, which is like this, then I simply have x to the power of 3. So it's not anything different than that right there. And then I may need to simplify afterwards, right? So I might need to simplify after I'm done. And we'll just look at an example, and then we'll see if we need to simplify. Where did my eye go? Trying to put my eye there. Okay, S and my S need to be fixed a little bit. So let's look at an example. So if I have example 1, I have 4 times 10 to the power of 5. Okay, in parentheses. And then I have times 2 times 10 to the power of minus 2. Let's follow my steps. I can multiply my coefficient. So what is my coefficient? Well, it's the sum number in front of my exponent here, right? So I'm just talking about multiplying 4 and 2, so that gives me 8. And then my actual exponent here, well, I'm still going to write times 10 here, and then I think, well, what is 5 minus 2? Well, 5 minus 2 is nothing other than 3, so I have 8 times 10 to the power of 3, and that's my answer. Okay, and it doesn't get anything, it doesn't get too much crazier. I could do example 3. So if you have the book, you'll see it there, but this one just says that I have, instead of all whole numbers, I have 4 times 10 to the power of minus 6. Oh, fix my 6 here, 6. And I have 6.2 times 10 to the 4 in my second parentheses. So 6.2 times 10 to the 4. So this does mean one more step here, because if I multiply 4 times 6.2, well, 4 times 6 is 24, right? So if I'm doing that 4 times my 2, then I end up with 24.8, okay? And then my times 10 to the power of here, right? What is minus 6 plus 4? If I owe you $6, I give you $4, I still owe you minus 2. Okay, so it's minus 2. And then, to be fully simplified, what my scientific notation says, I should move my decimal point over here, right? So that means that I'll have 2.48, and I'm moving left, right? Just like in my example above. So go back to my example above, 8,000, right? I move my decimal point to the left, so it may increase my exponent. So if I increase my exponent here, then it's 2.48. And then what happens? Oh, sorry. Did I write minus 2? Yeah, I did minus 2. So then over here, then it becomes times 10 to the power of minus 1. Okay? Sorry, my 2 is not super clear out there. And that's my final answer. And then if I really want to write this out in just regular notation, right, what happens? Well, if it's times 10 to the power of minus 1, what does that mean? Well, that means that my number is doing what? Well, it's changing by 1 decimal point, and it's not positive, right? It's minus. So that means my actual final answer, if I wanted to write it out just like this, then I would say it's actually what? It's 0.248. That's my actual number. That's not scientific notation, but that would be my actual number there, right? Because this minus 1 here tells me to move my decimal point 1, and it tells me to move it to the left.